Let's take a look at today's bell ringer. It says, explain what is occurring in the image above. So it's kind of hard to see, but this is actually what we call a Van de Graaff generator, and it's actually giving off basically electrical particles, and they kind of flow from the object, from the generator through your hand up into your hair, and your hair kind of stands up on end. So this does relate to static electricity, and in the Bill Nye video, they're actually going to explain it a little bit further. So if you weren't really sure what exactly was happening here at this point, that's okay. But it's basically just particles flowing up through your hand and kind of making you become charged up, and it makes your hair stand on end like this. So I'm going to start out by sharing with you guys a quick intro little video on the science of static electricity, and then I'll open up the Bill Nye document and talk about what you need to do to submit. So let me change my settings really quickly. Let me change my settings briefly, and I'll show you the first little short video clip.
It can strike without warning, at any moment. You may be walking across a soft carpet and reaching for the doorknob when suddenly, zap! To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one, in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark. This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons pop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature. In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens. It may have to do with the circulation of water droplets and ice particles within them. Regardless, the charge imbalance is neutralized by being released towards another body, such as a building, the earth, or another cloud in a giant spark that we know as lightning. And just as your fingers can be zapped over and over in the same spot, you better believe that lightning can strike the same place more than once.
All right, so hopefully you guys found that interesting. That's kind of our introduction to this whole idea of static electricity. So some of your tests tomorrow will be on general electricity and some will also be on static electricity. So for today's activity, if you click on virtual students, absent students only, you're going to scroll down and you'll see the Google Docs for Bill Nye, and you'll also see the link. Now I'm going to share the video with you during class. At the end of class, we're going to go over the answers to the video, and I'm going to go over to the answers to the Bill Nye video you watched earlier this week. That way you have both of them. So if you have not opened that document from earlier in the week, you need to do that so that it's ready for when we review the end of class. Those two assignments, this one and the other Bill Nye, which was shown to you guys on Monday, again, those will kind of be your study guide. So we'll go through those and then I'll answer any questions that you guys have, talk a little bit more about what you guys can expect on the quiz. And that should finish us up for the day today. And I'll also answer any questions. Some students have been sending me messages about makeup work or extra credit. And I don't do extra credit, but I'll tell you some options that you have for making up some missing assignments. So I'm going to go ahead and get ready to play this Bill Nye video now. So please listen and work to fill in some of those blanks as the video plays.
Right now, charged particles are flowing through your television set. That's electricity. But sometimes the charged particles don't flow. They build up and they build up and they build up and they make big sparks. Whew. That's static electricity.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by socks. Socks stick together.
Lightning bolts and sparks happen when electricity makes air glow. Now, electricity is the flow of tiny particles called electrons. And you know about electrons because they're flowing through your television set right now. But this is static electricity. And static's from a word that means stay. So the charged electrons are staying on that big ball, and they build up a big charge. And then the charge lets go. The electrons start flowing. Isn't that wild? It's lightning. You've probably felt a static electrical charge if you've ever shuffled your feet across the carpet and touched a doorknob or somebody else. Well, here's what happens. As you rub your feet on the carpet, electrons, the tiny pieces of atoms that have electrical charge, build up on you or the carpet so that there's a static charge. Now, by rubbing this fur on this red plastic rod, I end up with electrons on the rod. It has a static electrical charge. So watch what happens when I bring it near this silver-painted ping pong ball. Look, they attract. See? They're pulled together because they have opposite charges. Now, there's an old saying, opposites attract. And it may be true for people.
Oh, Bill.
Oh, gosh. But it's certainly true for electrical charges. Now, suppose we want to make a big static electrical charge. Well, we could use something like this. This is called a Van de Graaff generator. It's named after Robert Van de Graaff. So here's what happens. Electrical charges are deposited on this rubber belt. The rubber belt turns and redeposits the electrical charges up here on this metal ball. Now, since this next part of the demonstration rocks, I'm gonna put on my rocker wig of science. Yeah! Now, start the rubber belt turning. Electrical charges are being deposited on the metal ball. They're running through my arm and being deposited in me. And look, it's building up in my rocker wig of science. See, since these charges are all the same, they're not attracting. No, they're repelling. They're pushing apart. So they're pushing the hairs of my rocker wig apart. Now, if I could find a way to get these electrical charges off of me back into some other parts of the room, the hairs wouldn't repel each other. There wouldn't be a static electrical charge. No, the charge would jump. Let's try it. Watch what happens when I bring this ball near this ball. See the spark? The charges jumped. The static electrical charges aren't static. No, they jumped. Static electricity. It rocks. See that? It sparked. Hey, Elaine, how's it going?
Oh, hi, Bill. It's going good. Who am I fooling? It's no use pretending anymore. Every time I do my laundry, I get this embarrassing electron buildup.
Oh, you mean static cling?
Oh, fine. Here I am with my clothes full of electrons, creating a negative static electric charge, and all you can say is static cling.
Well, have you tried spraying it with water?
Huh?
The water absorbs the electric charge. Look. See? Doesn't stick.
But now it's all wet.
Well, what can I tell you, Elaine? I mean, it's a process. I mean, you know, it doesn't happen all at once. I mean, first the laundry's in the dryer, spinning around in that desiccated atmosphere. You know, there's no humidity and there's very little water in there. So the electrons, with the friction of the spinning, they can build up on one surface or the other, either on the shirt or the sock. So the electrons, there they are.
Boy, this guy can really go on and on when it comes to static cling. He just goes on and on, and my sock's all wet.
So the sock doesn't stick. I mean, laundry doesn't happen all at once, you know. Sorry.
Here are 3 fun things you can do with a balloon and your hair. 1. Rub a balloon into your hair. Stick it to a wall. 2. Get some sugar. Now, rub the balloon in your hair. It makes a sugar storm. 3. Cut little people out of paper. Rub a balloon to your hair. The people dance. Static, static, static.
Science! Static electricity! Static!
So get this, everything has electrons, and electrons are tiny little charged particles that are part of atoms.
Static on radios and televisions is caused by static electricity on dust and water vapor in the Earth's atmosphere, which the antennas pick up. And now, some more static.
Now for something
Really shocking!
Here's the static electricity generator, just full to the brim with electrons. I'm gonna let some of the electrons jump off. We scientists like to say, I'm letting the electrons discharge. Now, where do they go when we discharge them?
home, maybe? I don't know.
Well, they go into the ground.
Oh,
Now, when you say the ground, do you mean the ground? Like the Earth? Like part of our planet?
that's what I was thinking.
Yeah, the ground. Well, how do they get there? With a ground wire.
What?
The ground wire runs from the machine right to the main cold water pipe in the lab. And the cold water pipe runs right through the floor. The pipes run underneath the floor of the lab, all the way down here, and then into the earth. That way electrons can find their way to or from the ground, just like that. You may have seen a third prong on some electrical plugs. Well, that's the ground wire. It lets extra electrons get to or from the ground quickly and quietly. Well, thanks for joining us on Consider the Following. Discharge electrons.
Oh, Bill.
Discharge to the ground.
Bill.
Did you know that?
Lightning can strike backwards from the ground to a cloud. 50 to 100 lightning bolts hit the ground every second all over the earth.
Now you know!
They won't make a mess on your pants or your dress. Roll over, sit over, do tricks. But they'll stick to a wall in a room or a hall. Balloony sticks, balloony sticks. Just fill them with air, start rubbing your hair with the wackiest toy that you know. Then tell all your friends to buy 9 or 10 from Statico. Balloony sticks.
Balloony Sticks, the balloon toy that sticks to walls. From Statico.
Tales from the Lab with your host, Bill Nye.
Here it is. Once upon a time, many, many years ago in Greece, there lived some pine trees. And although the pine trees eventually died, some of their sap hardened into a gold-colored substance we call amber. Many years later, amber played an important part in a movie about dinosaurs that made lots and lots of money. Anyway, many, many years before that, a Greek philosopher named Thales took some amber of his own and polished it with a cloth. He noticed that after polishing, the amber would attract small objects like dust and hair. We know today that Thales was rubbing electrons from the cloth onto the amber, making the amber negatively charged. The Greek word for amber is electron, which is where we get the word electricity. The end. Electric motors, like the ones in blenders, can make electrical noise that looks and sounds just like static. Electric motors also can help you make a mighty mean banana milkshake.
Third down and 4 now. Ball is snapped. Hand off to Electronsky.
Oh, not again, Bill! I'm trying to watch the game! Turn off the blender!
Field rapidly now. And he's driven out about the 40-yard line.
Are you feeling dull, boring, negative? Like everything is the same old, same old? Well, worry no more and let Johnny Static give a charge to your life. Not to mention your hairdo. Johnny's unique style of hair design has helped to add a spark to millions of people like yourself. So act now to add a jolt to your hair tomorrow.
Hey, we're on top of the Space Needle in Seattle, Washington. About 184 meters off the ground. Now, this is the closest thing to a cloud. So, we've got lightning rods on it. There's 24 lightning rods, about this tall, and there's one big one. So if an electrical storm comes along, the electrical charges are going to find their way to the ground through one of these things. Pretty cool, huh?
Careful.
Here are 2 fun things you can do with your hair and a comb. 1. Cut a square paper. Tape it in a roll, like this. Then, comb your hair very fast. Hold the comb near the paper. Wow! Neato! 2. Comb your hair again. Now hold the comb near running water. The water bends.
Electrons went from your hair to the comb. All those extra electrons are what pulled the paper.
The comb built up a negative charge. That's what pulled the water molecules.
Static!
Hey, you, get yourselves a pencil.
Because you're going to need it later.
Static charges build up on things when they rub together, right? Well, try this. Get a plastic soft drink bottle and a glass one. Rub the plastic one with a wool sweater. Set it down on edge like that. Now rub the glass one with a piece of silk you might have lying around the house. What happens when you bring them near each other? Try it. I said try it!
When you build up these tiny little charged particles, you get static electricity.
Uh-huh.
Did you know that?
The safest place to be during a thunderstorm is in your car. A flash of lightning may be up to 140 kilometers long.
Now you know!
You can make your own precision static electricity detector called an electroscope. Yeah, all you need is a peanut butter jar. Of course, it's got to be empty, like this one.
Mm-hmm.
Then you need a coat hanger. And you may want to get an adult to help you with this part, but cut the coat hanger in 2 places like this.
Watch yourself there.
And now we want this piece of coat hanger to go through a hole in a peanut butter jar lid. Now, a great way to do this is with a pair of pliers and a candle. You definitely want an adult to help you with this part. After it's warm, push the coat hanger through the peanut butter jar lid. Oh, look at that. Oh, look at that. Now that right there, that is a great hole in a peanut butter jar lid for a coat hanger right there. That is a great coat hanger. Now, this piece of aluminum foil, cut it with scissors. Use your fingernail and smooth it out. Fold the piece of aluminum foil over the hook part of the coat hanger. Now screw the jar back together. Secure the coat hanger with a little piece of clay.
How long is this going to go on, Bill?
Then we need an electrode ball. You can use a piece of aluminum foil. Roll it into a ball and stick it on top of the coat hanger. Now you need some static electricity.
You're good at that. You're a little too good at that, Bill.
Look, the leaves of aluminum foil push apart. The leaves of foil are moving and I'm not even touching it.
So?
I think it's pretty cool. It is cool. It's an electroscope right here in a peanut butter jar.
What can you do with a jelly jar?
This is how lightning works. Electrical charges build up and they push away from each other. Eventually, they push away from each other so much, they end up falling to the ground. With this, I could...
Dare I say it?
Rule the world! Well, maybe not, but it's pretty cool.
Now for something really shocking!
When lightning strikes, it heats the air to over 30,000 degrees Celsius. Hot air smacks into cool air, and that makes thunder. Lightning and thunder, they come from static electricity. Jumping electrons.
I think they're in for a surprise.
I send electric arcs directly into wet paint on glass. Don't try this at home, and it spreads the paint and moves through it and does things that I wouldn't get any other way. This is weird science, if you will. I'm using weird science to make art objects. I'm actually sending miniature lightning bolts into wet paint on glass. And the electrons come streaming out of the lightning brush, trying to get to ground. Mysterious, strange, this is cool science. Out of that rod comes 1.5 million volts of lightning. It jumps through the air, hits the wet paint on the glass, and gives me elegant surprises. New things that I would not find any other way.
Static electricity isn't always static. That is, it doesn't always stay in one place. Sometimes, when it builds up enough, it can jump from one thing to another.
I got some amber, I got some cat fur. I think I'll rub one on the other and see if the electrons will gather on one and build up to charge it negatively. I'm on a roll, I wanna rock, I wanna give you such a shock with static electricity, particles sparking. Electricity, it's static electricity, it's really shocking. It's static electricity, people are talking. Electricity, it's static electricity, it's really shocking. Electrons, when they gather together, they make a negative charge, the start of a spark. In clouds, when they build up, it really is no wonder that when they discharge, it's lightning and thunder. Lightning. And that is electricity, it's static electricity, particles sparking. Electricity, it's static electricity, it's really shocking. It's static electricity, people are talking. Electricity, it's static electricity, it's really shocking.
All right, ladies and gentlemen, so hopefully you finished that. I realized, I'm gonna turn my camera on really quickly. Hello, everyone. I realized that I think I attached the answer key to the static electricity worksheet, which is fine because I was gonna go back over it with you anyway. So if you got the file that has the answer key for static electricity, just make sure you still type yours in and submit it, okay? So remember, the big key difference between static electricity and regular electricity is that static electricity builds and builds and builds and builds and builds, and then bam, then there's a spark, or then there's the transfer of buildup of charges, okay? So that's kind of the primary difference there. So in the video, he kind of gave you guys some examples. So remember, static electricity came from the word that means stay. Electrons build up and then eventually start flowing. That's lightning. That's basically what you see in a lightning storm. A static charge occurs when electrons build up on something. Number 4 in your answer sheet talked about opposites attract. And I'm just going to kind of go through these because I realize you guys, does everybody give me a thumbs up if you guys noticed that answer sheet was attached in that document? So in the Google Docs, somehow the answer sheet got in there. Is that for everybody that's in here? Okay, that's what I figured. Not a big deal because I wanted to go over it with you guys anyway. So just make sure you do your portion and submit. Opposites attract. So if you have a positive charged object here and a negative here, they will attract to one another. They don't necessarily have to touch, but they will form an attractive force. And so one example was the comb, right? She brushed the comb in her hair and she held it close to the water, and even the water kind of curved toward the comb. So two objects don't necessarily have to touch in order for them to exert a force, right? And push or pull on one another. Let's see. Remember when he had on the rockin' wig of science and he had his hand on that Van de Graaff machine or generator? his hair stood up because they all began to repel one another. So they all kind of had the same charge. When your clothes stick together in the dryer, that's static cling. When electrons jump, remember that's a discharge. So when you see that pop of static charges, that's the electrons kind of discharging there from one object to another. So it can be from you to the doorknob or you to another person. Again, most of these you guys should have been able to fill in there. Let's see. For number 14, it talked about the Space Needle. Now, the reason why tall buildings have those lightning rods is to prevent lightning from striking the building and causing any damages. So if they have the lightning rod, it will strike the rod itself and kind of transfer the energy that way instead of hitting the side of the building or something like that. So that's a good example there. The safest place to be is your car in a storm. And then static electricity isn't always static. It can transfer from one object to another. So it said that means it doesn't always stay in one place. So it can move around and sometimes it does. Okay. Now, earlier in the week, you guys did the electricity video in general, right? So Monday, I believe it was, you went through the video example where they talked about electrons. So what I'm going to do now is I'm going to kind of talk about those. So if you want to check your work, you need to pull that document up now. So I'll give you just a moment to get that done. So if you want to go into Monday's folder, so let me make sure that's the right place. So in Monday's folder for virtual students, you should see a Bill Nye worksheet. Yep, virtual students only, Bill Nye electricity. So if you open that up, you guys will see it and you can check your answers now. So I'm looking and a few of you have submitted. So if you want to check your work now, here comes the opportunity to do that. So go ahead and open those up now. All right, so for that one, electricity from Monday, number 1, electricity is a flow of tiny particles called electrons. Also, remember that electron is flowing in a battery. We've been talking a lot about circuits. It always flows from the negative end out around the circuit and back through, so just something to keep in mind. Electrons, number 2, electrons are part of atoms. They're the particles circulating around the outside. Number 3, the word circuit means to go around. Therefore, a circuit is a pathway or a closed path around which electricity or water flows. So that was number 3. Number 4, electrons flowing through a wire can be compared to water flowing through a hose. Once the flow of electrons or water is going, work is performed. Number 5, you would get shocked in a bumper car by touching the ceiling and the floor at the same time. This means you are completing the circuit, allowing electricity to flow. Number 6, electricity from a wall outlet has enough energy to stop your heart. It's pretty scary, so be careful when you're plugging things in. Don't stick stuff in outlets. That's why that's important. Number 7, electricity is the flow of electrons because electrons move or jump from atom to atom. So in a nice even circuit with wires, like copper wires, it's usually a nice flow. But they will jump, let's say in static electricity, right? They build up, build up, build up, and they jump, or they pop, right? It's kind of a big release of energy. So that's kind of the two differences between static electricity and regular electricity. Number 8, materials that allow electrons to move easily are called conductors, metals, copper, iron, steel. Number 9, materials that do not allow electrons to flow easily are called insulators. Number 10, semiconductors are materials that are somewhat in between. Number 11, voltage is the force or pressure of electricity, and it's compared to the amount of water pressure in a hose. Number 12, current or amps is the amount of electricity and is compared to the amount of water in a hose. And lastly, watts is power in the term for work performed by electricity. So that kind of fills everything in for that worksheet. So on your quiz tomorrow, it's going to be electricity, static electricity, and then also circuits. You were assigned a circuit lab yesterday. Remember that if the circuit is in one continuous loop, right, that's called your series. And if you cut the line, all the bulbs will go out. Parallel, on the other hand, has branches, kind of like a bridge. So if you have branches in a circuit, then if one branch goes out, the other branch will keep working. Parallel circuits tend to pull more energy, and series tend to pull less energy. So if you worked through that lab activity yesterday, you should be well prepared for circuits. And we've been talking about them in class. Okay, so that's it for your quiz tomorrow. Static electricity, and circuits. Last thing I want to mention, I've had a few people who've been asking me about extra credit work, and some of those people aren't even here in the WebEx, but here's what I'm going to tell everyone. If you missed that Nearpod that was months ago, almost 30 days ago, a month ago, I'm not going to reopen that. But if you want to do one of the other days of classwork that didn't necessarily have a grade attached to it, then I'll give you some partial credit for that in lieu of the Nearpod. So I've had a few students ask me about that, but those codes are expired. I'm not going to go back and make another one. So if you missed the Nearpod, but you want to do an alternative assignment to get a few points, tell me and I'll give you partial credit. So if you look back through Schoology, you will see there's some days I assigned classwork, but I didn't actually grade it. So if you go in and do that, and you say, hey, Miss Littlepage, I did this assignment. Is there any way I can get some partial credit for zeros that I have in the grade book? I'll be happy to do that. So I'm not going to give you guys extra credit work, but that option is available. All right. So does anybody have any questions? Here's your chance to ask. All right. Well, if you guys don't have any questions, you're good to go. I've gone over those 2 videos. Those are your study guides for the test. Good luck. I'll see you in class tomorrow for quiz 3. Have a great day, everyone. Bye.